For this problem, I decided that I wanted my angle measure to be 80 degrees and my p-value to equal 10. And what the p-value essentially is it's the sector area divided by the arc length. So in this situation, the sector area divided by the arc length is going to be 10. And in order to make this a little bit easier for later on in the problem, I determined sector area to be x and arc length to be y. Now this is written wrong on the screen, but it's supposed to be x over y is equal to 10. And um, what I did is I simplified that, or made two different equations that are going to end up being used later in the problem. So one of those is 10y is equal to x, or x over 10 is equal to y. So the first thing that I was solving for was the sector area. And in order to solve for that, I had to set up a proportion, which was 80 over 360 is equal to x over pi r squared. And the reason that it's over pi r squared is because that is how you find the area of a circle. And the reason that this is the right proportion to use is because I'm comparing a part to a whole. So I'm comparing the part of 80 degrees to the whole of 360 degrees, and then I'm setting that equal to the part of the the area, so the sector area, which is part of the whole entire area, over the whole entire area. And so I cross multiplied those, and I got 80 pi r squared is equal to 360x. And so I decided to make it easier, I was going to solve that for x. So I divided both sides by 360, and so I got x to equal 2 pi r squared over 9. Next, I solved for the arc length. And in order to solve the arc length, I once again had to set up a proportion. And that proportion is 80 over 360 is equal to y over 2 pi r. And just like when we were finding the sector area, the reason that this proportion works is because it's comparing a part to a whole. So it's comparing the part of 80 degrees to the whole of 360 degrees, and it's comparing the part of the arc length to the whole entire circumference of the circle. And so I cross multiplied that proportion to get 160 pi r is equal to 360 x plus 10 x divided by 10. And the way that I got the x divided by 10 was on the first slide. I figured out that y is equal to x over 10, so I just substituted that into this equation so I could get rid of the y variable. And so next I divided that whole thing by 360 to get 4 pi r over 9 is equal to x over 10, and then I multiplied that whole entire thing by 10 to isolate x, and so I got x to equal 40 pi r divided by 9. So my final step in solving for the radius is to set the sector area equation and the arc length area equation equal to each other. And the reason that I was able to do that is because in both situations I isolated x. So since both the equations are equal to x, the x value is going to be the same for both of them, so I was able to set them equal to each other. So that gave me 40 pi r over 9 is equal to 2 pi r squared over 9. And so I cross multiplied to get 360 pi r is equal to 18 pi r squared. And then on the left side, I divided by r, and then on the right side, I divided by 18 pi. And it's only written as 18 on the screen, and I meant 18 pi. But yeah, so I divided by 18 pi so I could get r isolated. And when I did that, I got the radius to equal 20.